Hi, this is John. 3D printers have become widespread, and obviously we're interested in how we can use them in rocketry. For small parts, printing them directly makes sense, either through commercial services or on home printers. But for printing large parts for larger high-power rockets, those exceed the build volumes of most home printers. This video is about how you can print larger parts in multiple pieces using an easily available home 3D printer. For example, this 6-inch nose cone was printed in 3 parts.
I needed a 6-inch nose cone for my Ariane 6 model. In the past, I would have had to mold one out of fiberglass, but this time I tried 3D printing. My Prusa printer, of course, doesn't have a large enough build volume to build this in one piece, so I split it into 3. First I drew it whole, and then I split it. Here you can see how it looks after it's been split. The tip is one part and the base is 2. There's also a shoulder that fits inside a 6-inch coupler. On the forward end of the 2 base pieces, I molded a rabbet so that the cap could fit tightly and lock everything together. Another thing I discovered after a few false starts was molding gussets helps preserve the shape during printing and prevent it from deforming afterwards. Printing the 3 pieces goes pretty much as you expect. The little machine does all the work. And here are the 3 pieces ready to bond together. Epoxying these pieces is pretty much like other high-power epoxy projects. Prepare the surface, clean it, sand it, and then apply epoxy and let it cure. You can see how the 3 pieces fit together and fit inside the section of coupler tube, giving me a whole nose cone with shoulder. The inside was finished in the usual way, with a ring to hold a bulk plate to store electronics in the nose, such as trackers or secondary recovery. Because the gussets have holes in the center, the electronics can go all the way up into the tip of the nose. The booster nose cones were even more elaborate. I ended up making these out of 5 different parts. First I drew the outer shape of the whole thing. Then I separated out the base section, which included the coupler that would fit inside the airframe tube. The midsection of the nose was split vertically in 2, as was the tip, which also had to accommodate a piece of aluminum in between. One problem I ran into was that a part that was printed double thickness ended up warping a bit, as you can see where it diverges from the ruler. The fix for this was to thin the wall as well as create a small relief. Another problem I ran into was some of the parts didn't fit correctly. Part of the problem is the rough edges on the underside of the outer lip where the support material attached. The fix for this is to make this part a little thinner from the inside, as well as clean it up more thoroughly, sandpaper and a knife, before bonding. 3D printing can indeed work for high-power rocketry, at least for rockets which aren't going to achieve extreme velocities. In this case, my sport-scale Ariane was much easier to build without having to make a fiberglass mold.